Investigate vertical transformation. Describe the transformation, sketch the graph, and write domain and range for the given functions. So we have two functions here. One is f of x equals to 2x squared. The other one is f of x equals to minus half x squared. The purpose of giving them is to explain you what kind of vertical transformations can take place when we are talking about stretch and compressions. So in the first case, when we multiply the function by a number, then it is vertically stretched or compressed. If the number is more than 1, then it is vertical stretch. So here the transformation in A will be vertical stretch. So in general we normally write like this: f of x equals to k times x squared, right? And if k, the magnitude of k, is greater than 1, then it is vertical stretch. But if magnitude of k, absolute value, is less than 1, in that case it is vertical compression. And these are by a factor of whatever the number is here. So we say vertical compression by a factor of. In this case, let me write k in general. Here, vertical stretch by a factor of k, right? So that is what it is. So in this case, you can write vertically compressed by a factor of half, and this one is vertically stretched by a factor of 2. So that is what this k factor gives. So k is half, that means it is less than 1, so it is vertically compressed. Now, if we have negative here before it, negative says reflection on x-axis, right? So if you have a negative number here initially, then it means the reflection. So that indicates reflection. So we can say if the value of k is less than 0, if the value of k is less than 0, it means reflection on x-axis. And that is also vertical. So if you have something here and it reflects here, then it becomes reflection on x-axis, correct? So that is how we can explain the vertical stretch, compression, and reflections, right? Most of the time, we are actually writing in general the functions as f of x equals to a times x squared. So we use normally the letter a to write in general for vertical stretch, compression and all. And we write normally k as inside function, right? But it's basically a constant. So what is k here? K or a, they belong to set of real numbers, right? So where k or a, whatever, it belongs to a set of real numbers, right? What I'm trying to say is any constant which is getting multiplied with the function, that is what you have to see. If that constant is negative, then it means reflection on x-axis. If the magnitude of the constant is greater than 1, then it's vertical stretch by a factor of that constant. And if the magnitude is less than 1, then it is vertical compression by that factor, right? So let's try to sketch and see how does it look like. X square graph is simple to draw. So you start with origin 1 1, and then you can follow steps 1 3 5 7. I hope you know these steps, right? Whenever you have to draw x square function, then we can follow steps. Steps are 1 3 5 7, and they start with vertex, and for x square the vertex is 0 0. So we are at 0 and we'll follow 1 3 5 7. That means move 1 unit and then 1 up, and then move next unit, may move 3 up. So we from here 1 2 3, 1 3, and next unit 5 up, 1 2 3 4 5. You get the point like this. So once you have drawn on one side, the other side is mirror image, because x square is even function, right? So it's just a mirror image. Or you can go 1 3 5 7 again, count and then write down, right? So we get our parabola here, and let me draw this function now, join these points. When you join them, make it round at this point, right? And don't forget to put an arrow here, because x tends till infinity. So that is our function x square. Now, on the same graph, let us draw the function 2 times x square. 2 times means multiply each value by 2. Only the y values, x remains same. So here y is 1, 1 times 2 is 2, so it comes here. The y is 4, there's 1, 2, 3, 4, 1, 2, 3, 4, 4 more units. Similarly, these places, right? So you get your transformed points. Join them. So this function is 2x square. 2 times whatever we had. So you'll observe that if on the original function the points are x and y, then they get transformed. X remains same, but y points becomes 2 times y. So that is how the transformation is. In general, if I write a function fx equals to a times x square, then how the points will get transformed? The original points, let us say, are x and y, then they will transform as x and a times y. So that is how they get transformed. So that is, in general, the very right way of writing. So here, even here, it will be a times y, where a is minus half. Do you understand? It takes care of both the things, reflection and compression by a factor of half. So I'll appreciate, do this exercise yourself and then see how will it look like, right? Reflection, it will get reflected on this side, and compression means squeeze it, like. So I stretched it earlier, so it will be like half. So it will look more flatter, right? So draw that graph and see it for yourself. How does it look? And get a feel of it. And then we will do some transformations where we will involve both vertical and horizontal transformations. That means stretches, compression, translations, right? And let's see how it goes. Thank you. All the best.